So in the previous session, we have looked into word tokenizer, sentence tokenizer, and tweet tokenizer, and we have also looked at the difference between each of them and their significance as well. So in this final session, we will also have a look at another type of tokenizer, that is a regular expression tokenizer or regex tokenizer, and we will actually look that into action. So it will be available under same nltk.tokenize library, and it is available as a class but not as a method. So this we have to be very careful about this. See, in order to differentiate between these things, we can actually see that this sentence tokenizer is actually in the smaller case, right? So SENT is in the smaller case, or the word is in the smaller case at the beginning. But by this we can able to differentiate between the classes and the methods available. So this tweet tokenizer and regular expression tokenizer is actually available as a classes. So if you just hover on that as well, you can actually see it as a method, it as a class as well. So I have imported that over here. Now it's time to initiate that as a object. So I have taken a regex tokenizer as a like variable where I am going to initiate this class and assign that into this object. So for this, we have to initiate with a regular expression first, and then we have to set this parameter gaps equals to true or false. So based on that, it will consider whether the gap should be allowed or not. So that's the only criteria, nothing much about this. So we can actually define any kind of regular expression over here. Suppose our requirement was to split the sentence into tokens when we start with any character or any number, any kind of thing. So here I am just using a escape character, a reverse slash s plus, to tokenize individual words. Like I'm just using it as a word tokenizer as of now. We can actually try it out with different varieties of example, different varieties of regular expressions as well. So, and regarding this regular expression, I will be explaining those things in the next further session. But as of now, this is how a regular expression will be looking like. So it will be a string or a rule defined in the form of string, and this will decide the action of this class particularly. So I am guiding, or I am making this regex tokenizer to be constrained under this rule that you split the sentence into words based on this condition. Okay, so this is how a regular expression tokenizer will look like. So according to the current situation or the current condition, the regular expression, I am making a condition that you split the sentence into a single words or a single tokens. So that's what this reverse slash s plus indicates. Okay, so I am trying to initiate that as a class. Now it's time to look that into the action. So there is a method called tokenize over here as well. So regex tokenizer dot tokenize, and I'm going to pass the same sentence which I used for the word tokenizer over here. So Tendulkar took up cricket at the age of 11. So I have passed the same sentence over here. You could actually see that it has perfectly split that sentence into individual tokens. So this is a classic example of regular expression tokenizer. So it is more sophisticated when compared to this word tokenizer, because we can define any kind of rules, any set of rules, right? So we can just consider that now split the sentence based on the commas. So if you encounter any comma, then split that sentence based on that. So we can define any rule over here systematically, then the tokenizer will split that sentence into a particular category. So can we say this is a super class of all the tokenizer? Yes, we can say that, because we can include sentence tokenizer and word tokenizer, even the tweet tokenizer, to be working as a same using the regex tokenizer here. So this is how it is more advanced over all the types of tokenizer which we are available with. But if the use case is very much simple, we just want the sentence to be split into words, then we can directly go for this word tokenizer. We don't have to use this regular expression tokenizer. right? So if the case is very much advanced, if we want to split the sentence with particular condition which are not satisfied by any of these kind of tokenizers, then we have an option to use this regular expression tokenizer. So by this I am going to end this hands-on or a Python session on the different types of tokenizer which we understood theoretically, and we have also understood now practically as well.